Hear me? There we go. Welcome. Let's see. My name is Eldon Christensen, and I'm a PM on the Failover cluster development team.
My name is Amitabh Tamhain. I'm a PM at program. I'm a program manager at Failover cluster dev team. And welcome to the session.
All right. So today we're going to be kind of flipping back and forth between the two of us. Amitabh's going to be doing some of the demos here. And so what are we going to be talking about today? So what I'm going to be talking about in this session is going to be doing a feature overview of what's new in Windows Server 2008 failover clustering. So let me ask this question. So how many people have 2003 clusters deployed today? Okay, almost everybody. 2008 R2? Almost many. Okay, so who doesn't have 2008 R2 deployed yet? Okay, all right. And who has no clustering at all? Like one hand. Well, actually, that's fabulous. Okay, that's good. That's good. I'm glad to see that. So I'm going to talk about all the incremental feature differences between clustering in 2008 to 2008 R2. Some other sessions I'll just mention that's going on. Tomorrow morning at 8:30, Henry, who's another PM on the cluster team, is going to be doing a session on multi-site clustering. So if you're thinking about taking clustering and stretching it across sites so that you can achieve not only high availability, but also disaster recovery, that will be a session that covers that as well. And I'll be doing a session on Hyper-V planning tomorrow as well, where I'll just be talking, I'll really kind of narrow in on Hyper-V and failover clustering. So first let's talk about hardware. So for the people who are familiar with 2003 clustering, we used to in the past have this hardware compatibility list where you had to go and select your hardware. We've completely changed our stance with 2008 and 2008 R2 clustering. So in order for a cluster to be qualified, all you need to do is take, logoed components. So you go out and you buy a logoed server, you use logoed multipath software, you use logoed storage. And then we have a tool called Validate. And Validate is the interoperability test that makes sure all these components work together. You pass that, and it'll be supported. And actually, our hardware requirements are no different between 2008 and 2008 R2. They actually changed a lot between 2003 and 2008. We actually, for example, changed the SCSI commands which we used to manage storage. In the past, we used to use these SCSI2 reserve release commands. And so in 2008, we actually moved to SCSI3 persistent reservations. And moving to those is what actually addressed a lot of our interoperability problems. So if you guys were familiar with having, how did we get away from this model of not needing to have everything all be pre-tested? And it really has to do with the way we changed our SCSI commands. And that goes back to with SCSI2 reserve release that there were all these layers of interpretation as these SCSI commands would come down the stack. And the beautiful thing with these persistent reservations now is there's no layers of interpretation, so all these compatibility problems have gone away. So our support policy now is very, very flexible. Just buy logoed components and put it together. So Validate. So Validate, in the past, in the 2003 world, we used to have the story of we had this logo certification policy. And so some vendor would go and build a cluster, and they would go get their most knowledgeable guy who knew the most about their hardware as possible. He would know clustering inside and out, and he would manage to get this thing working once. He'd run this test, it would pass, and it would be blessed, supported. And then you as a customer would go buy this from a website, it would show up in a box with a whole bunch of different little pieces, and you were expected to put this thing together and make it work just like this person that he did back in the lab. And so you could achieve that with marginal success. So what we did is we actually built a functional test tool into the product. So what Validate does is it actually goes through and tests the cluster. So like the storage. Can I issue the SCSI commands from this node? Can I go and challenge from this other node and actually go arbitrate over LUNs? All the different things that would happen in the life of a cluster. And most importantly, when things go wrong and we have to exercise some of our decision making on who should stay up and drop out of cluster membership. So and it does things like test network communication between the nodes and really make sure that the cluster is set up that's going to work properly. And what you're about to deploy in production actually works. So what do we change in 2008 R2? So if you ran Validate on a cluster, it was originally designed as a kind of a pre-deployment tool, right? That before you were about to deploy this thing into production, that you would go run Validate. Well, Validate can also be a diagnostic tool that you can if you have a cluster which is deployed and you're having some issues, you could run validate on a configured cluster. Now, the one thing we realized was that the tests which ran on a configured cluster and the tests which ran on on a pre or post configured cluster, there you go, I said that, how I said that, the tests were the same. And we figured out that there was a lot of smarter things we could do, such as we could go look at the cluster configuration. We could figure out, is your quorum configured optimally? Have you changed some settings with the network communication that maybe we should, are they really configured per best practices? So we added a lot of BPA tests in 2008 R2. So fundamentally, it's the same test, but we just added some BPA tests if you run on a configured cluster, just to try to make it a better diagnostic tool. And with that, I'm going to bring up Amitabh, who's going to show you some of the things we've got with Validate.
Thank you, Ellen. So we'll quickly see how to run Validate and how easy it is to run the Validate. This is the Failover Cluster Management UI. As you can see, I have one demo file server set up and a couple of nodes and some storage. This is the Validate cluster link, which once we open, it would start the Validate cluster wizard, which you would list various tests that you want to run. It's recommended that you run all the tests, but we are going to, for interest of time, skip the storage part of the testing because we do a lot of in-depth storage testing that includes like listing potential cluster disks, arbitration of the disk, and persistent reservation. But depending on the size of the storage, it can take a while. And we just start the cluster, start the validate test. While this is running, I'll show you the report that already I have run before, and it includes the storage tests. As you can see, it lists what all different categories the tests are, and does it identify any problems. The problems would be identified as an errors. Warnings are something that you are not you are doing which is not recommended. So if you look at cluster configuration, it tells you there is a cluster core group, then cluster services and applications. If you just click on this link, it shows you the dependencies of the cluster core group and what kind of storage that is available for you to test. If you click on your services and applications, it tells me, okay, this is my demo file server, and that's the resource dependency graph of this this is deployed application, and whether it also does a bunch of other tests as part of cluster configuration. If you go to network, here we are seeing the warning sign. So it looks for various IP configurations, multi-subnet tests, and here it's in my demo cluster, I have only one network talking to between the two nodes, and that's identified as a problem, which is correct because in a deployment cluster, you would have at least two, we recommend at least two network paths between the two nodes or the nodes of your cluster. And if we quickly go through the storage tests, and if you look at, so what the validation tool does is it actually talks to all the nodes in your cluster, and it identifies which disks are actually shared between these two nodes. And here in this my demo setup, it lists these 4 disks as shared disks. With that, I'll hand off back to Ellen.
Yeah,
yep.
Question. Okay, so the question was around, is the Validate tool extendable, that we could add our own tests, that we could have different things? And the answer is no, not as it is today.
Okay, thanks.
Okay, let me flip back. This is kind of a cool room, actually. We're all kind of at tables. I don't know, I've never been in usually it's always just rows of tables, and this kind of feels more casual and this is kind of a nice atmosphere. Let me flip back. Wrong one. Here we go. The key thing to remember out of the Validate report is green check mark, everything good. Yellow means, hey, go take a look at this. Might not comply with best practices, but just go take a look at it. Something for you to evaluate. And red error means broken, clustering won't work, you need to fix it, not supported until you do. So that's just kind of the magical thing to remember about the validate report. Nice graphical representation and look for those things. So choosing storage. So what storage do you want to use with your cluster? Traditionally, the most common way that people deploy clusters is with shared storage, with some sort of SAN. So that could be either fiber channel based storage, iSCSI, serial attached SCSI, and the new one you'll see on the list here, which is actually new we didn't have before, which is FCOE, so fiber channel over Ethernet, which is now supported. There are, we have some FCOE solutions which are listed in the Windows catalog, so you can get a logoed FCOE device, and that is now supported with clustering. But you don't necessarily need shared storage. It's kind of you need some way for the data to be accessible to nodes. So if you're going to be failing over an application from one server to another one, there needs to be some way for that data to be accessible. Traditionally, it's done through SANs, but you don't really need a SAN per se. We don't have any hard dependencies on SANs. If you wanted to, you could use replication to get the data available to all nodes. That could be hardware-based replication. So if you want to take, your storage array and replicate it from one storage array to another one, which different servers have access to. That could also be software-based replication. We have vendors who plug in, who extend clustering. DoubleTake does it, SteelEye does it, that extend clustering to allow replication between the nodes. There's also application-level replication, such as Exchange. Exchange does replication of DAGs between nodes in a cluster, and that's doing application-level replication. So I guess the key point is that there are a lot of flexible choices in how you want to deploy. We don't have any hard dependencies one way or the other. That's the only point I'm making here. Yeah, question? No. So the question was, no SANs? Are you smoking crack, Eldon? You're crazy. So yeah, you could use, you just need some way to make the data accessible. You could use, you could have a local disk using software-based replication like DoubleTake. DoubleTake will actually take a local disk and replicate it from one server to another one. And then you just need to make sure the data is accessible to all nodes. So you couldn't do it just out of the box, but there are enabling solutions. Server core. So I just want to talk a little bit about server core, even though it kind of has nothing to do with clustering, but I wanted to talk about it more from an availability perspective. So core actually does help increase your availability, and it's something you should be thinking about when you're looking at clustering. More in the sense that it reduces the server footprint. There's no Internet Explorer. There's no media player. It has this amazing, sexy little UI. I don't know if you guys have ever seen it. It looks like a command prompt. Such an amazing UI. And what does that mean? That means if there's a critical patch for Internet Explorer, you don't have an Explorer because you're on core, it reduces the amount of patches that you will need. So having to bring your servers down less to apply patches equals more uptime. So that's what I mean by core can help increase uptime. It also reduces the server footprint and reduces the attack surface of the machine as well. So there's a little bit of security gain, but I think the main gain from an availability perspective is that it means fewer patches, less downtime for patches, and that increases availability. So cluster migration. So we have a migration tool which we built in 2008 and we enhanced in 2008 R2. So the migration tool enables you, let's say you have a 2003 cluster that's up and working and you want to move it to 2008 R2. So this allows you to copy all the cluster configuration state from this cluster and copy it over to this cluster on the other side so that you can move things from one cluster to another one. Some of the big enhancements is that with the migration wizard is before we only supported going from 2003 to 2008. Now with R2 we can go from 2003 to R2, 2008 to R2, or even R2 to R2 if you want to do a migration from one set of hardware to another one. So failover clustering, we're really the infrastructure. If you think about the private cloud, we're also the infrastructure which enables Hyper-V to achieve high availability, and it really kind of enables you to deploy a private cloud to enable virtual machines to move across this pool of a cluster. And so I'm going to talk about some of the different things which we've done to help enable that. So in 2008 R2, we worked on increasing the scalability which clusters can handle. And we're also tightly integrated with Hyper-V. You'll see a lot of the things that we expose through our UIs for Hyper-V. So we expose creating VMs. We expose configuring virtual machine settings through our UI. So we have this tight integration with Hyper-V to help enable this. We also increased our supportability up to 1,000 VMs on a cluster. So that's from the old school cluster guys in the room. That means we support 1,000 groups and over 2,000 resources on a cluster. So we had to do a lot of infrastructure enhancements and clustering to be able to enumerate and display and give a good user experience for managing that number of VMs. So we did a lot of work to make clustering scale to that level. Because in the past, if you think about the way we worked with a SQL instance, with SQL, for example, you're maybe talking 10, 12 instances, 20 instances at most, maybe 24. So that's 24 groups, where here we're talking 1,000 groups. So just to get some context of kind of the scalability work we had to do to be able to support this level of infrastructure from the cluster side. Live migration. So I'm going to talk about live migration. So live migration enables you to move a virtual machine from one server to another one with no impact to the client. So the client is actually unaware of the migration, allows you to move it during to get planned downtime. So if you think about planned versus unplanned downtime using Hyper-V on a failover cluster. So for planned downtime, you can move a virtual machine from one server to another one with zero downtime. And for unplanned downtime, we have failover clustering is health monitoring the state of the virtual machine. And then if the server becomes unavailable, we will go start those virtual machines on another node. And that's effectively like a cold restart of the VM as a way to think about it. So let me talk a little bit about what live migration is and how does it work. So live migration is for planned downtime. It enables a virtual machine to move from one server to another one with zero downtime. The way it works is you have a VM which is up and running, and you have all the run states. So let's say you allocate 2 gigs of RAM to a virtual machine. So you've got 2 gigs of run state, and you need to move this from one machine to another one. So what happens is that we take the 2 gigs of memory, and we push it across the network over to the other server, and we pre-stage the VM. So while we're copying that over, that takes a little while. So let's say that takes, 20, 30 seconds. Let's say it takes 30 seconds, depending on your network bandwidth between the nodes, to push over those 2 gigs. So all the while that's happening, the VM is changing over here, right? We're copying it over, and the VM is changing. So we're tracking all the changed dirty pages in memory of what's changing on the VM while that's running. Then what we do is we come back and we make another pass. We look at the virtual machine and we say, okay, what pages are now dirty? So we pushed over 2 gigs initially. That took 30 seconds, and now let's say we have 200 megs worth of dirty data. We take the 200 megs of changed data and we push that across. And that goes faster, right? Because it's a smaller set of data. So let's say that's 10 seconds. And then we're still tracking, and we come back again, and we say, now what's changed? And we just keep making multiple passes and multiple passes and multiple passes, and each pass gets smaller and faster and smaller and faster and smaller and faster until we can actually do a cold cutover. So then the VM has actually failed over to the other machine. And then what kicks in, what's kind of the magic of makes live migration transparent is TCP reconnects. So this happens usually in under a second. That we call it the brownout period, where we're doing these multiple passes and moving the VM in multiple passes. And then when we get down, we have a blackout window where we actually cut off the VM and move it over. And that's usually about a second. A lot of times people will use ping to evaluate a live migration. A lot of times I'll see these questions come up, people going, hey, I was doing a ping, and I noticed I dropped a couple packets. I thought live migration was supposed to be completely seamless and transparent. Well, you're using an IP protocol. You're measuring at the IP layer, right? You're not measuring at the TCP layer. What makes live migration completely transparent to client applications is because they're working at the TCP layer, and TCP reconnects makes it completely seamless. So clustering for the last decade, in the past, had a shared nothing storage model, which meant that a LUN was only accessible to one server at a time. And so if you wanted to fail over an application or move an application, you had to move the storage with the application. So this created some challenges. So let's say you wanted to have, let's take a step back. On my private cloud, I really want each virtual machine to be an independent unit of failover. I want each VM to be able to move around and be liquid across my cloud, right across my cluster. Well, in order to accomplish this, because each LUN has to be associated with a VM. If you wanted to deploy 1,000 VMs, it means you needed a one-to-one relationship of a VM to a LUN, which meant 1,000 LUNs. That posed some problems in the sense of managing that number of LUNs, right? In configuring MPIO, in the scalability, running out of drive letters. Then you had to use volume GUIDs. I don't know if you guys ever used volume GUIDs with 2008 with Hyper-V and going whack, whack, question mark, whack, this big long GUID. Very unintuitive and not very friendly to use. And just poor capacity planning, right? That you'd have to provision all these different LUNs and all this storage, and then one would fill up and you need storage for a different one. Excuse me. CSV. So what CSV is allows all nodes in a cluster to simultaneously access an NTFS volume. We give a single namespace across all the nodes in the cluster. So we basically build a mount point. So on your C drive, we create a folder called cluster storage. And under there, we create a folder for each volume called, volume 1, volume 2, volume 3. You can rename it to whatever you want, but that's the default naming. And then that is the way and we just use reparse points to create this directory structure. So on all the nodes in the cluster, and we keep it consistent, you see the C cluster storage volume 1, for example. This allows all nodes to access volumes through this namespace, and they all can simultaneously access the NTFS volume. Oh, excuse me. Voice is giving out. So CSV. So here's a 3-node cluster. I've got a single volume with a single file system. We support many volumes. We support many LUNs, multiple volumes. This is just a nice simple example. And we have no restrictions on the Windows side as to how many LUNs we can support. And so here I've got 3 VMs which are running. They're all accessing a single common NTFS volume, and each VM is exclusively accessing its own VHD. So CSV is fully compatible with even the hardware you have with 2008. There were really no new hardware requirements from 2008 R2 or special hardware requirements for CSV. So there's no file type restrictions or directory structure depth or limitations. It's just a normal NTFS volume. CSV, yeah, question? Yep. So the question was around VMware has some limitations on the number of VMs that you can put on a VMFS volume. And the answer is no, we don't have any limitations on the number of VMs. And the reason with VMFS, they actually use, in up till 4.1, they used SCSI2 reserve release commands that I was talking about earlier that we used to use to manage metadata updates to VMFS volumes. And so they have some scalability problems in that when you lock a LUN, it blocks all the other nodes, so it doesn't scale really well. We actually do our orchestration for metadata updates at the server side level, so we don't have any limitations. Yes? Yeah, so the question was, what about formatting and partitioning a CSV volume? Yes, it's just open disk management. You create an NTFS volume and enable it for CSV. Excuse me. Sure, absolutely. And can you resize them? Yes, you can open a CSV volume. Yes, you can open disk management, and you can either dynamically extend or shrink CSV volumes as well. Without losing data, yes, you can do it on the fly. So let's talk about some of the fault tolerance which CSV brings. So CSV brings more than just being a distributed file system. So we actually have a filter driver which is looking at all I/O which is coming down in a CSV volume. So we have this filter driver, it's looking at all the I/O, and what we do is we do some orchestration of I/O. So when we look at metadata updates, we're actually sending those over to the other node to synchronize them through one server. Reads and writes are going down directly to the disk. Well, our filter driver also has failure modes where if we detect that the storage becomes unavailable beneath us, we can actually redirect all I/O over the network. So the scenario here, let me paint the scenario. I got a 2-node cluster which is up and running. I have some storage, some fiber channel connect, right? And Bucky, the evil admin, is staggering around through the data center and trips over the fiber cables, right? Well, you say I got MPIO. Let's say he trips over all the cables. You have now lost all storage connectivity to the LUNs. Traditionally, This would be really bad, right? The VMs would crash and horrible things would happen. What CSV will do is CSV will recognize the storage failure, get the I/O failures back. Then we will go and reroute I/O through over the network to another node, which will then execute the I/O on its behalf down to the storage array. So let's say you had a 16-node cluster up and running. As long as one node has accessibility to the storage, you'll be able to write to the VMs, to the VHDs. So here's the whole scenario if you pull it together. So somebody walks through the data center, trips over the fiber cables, yanks out, you lose storage connectivity. We start routing I/O over the network. So this common question is, doesn't that have degraded performance? And my answer is yes, it does. Your Ethernet cable might not be as fast as your high-speed fiber channel connect. Actually, if you have 10 gig E, maybe it is. But I kind of think of it like as a run-flat tire. You can't really go down the Autobahn at 100 miles an hour, but it allows you to get to the gas station so you can change your tire. Same sort of thing, is that your cluster is now up and your VMs are still available, maintaining high availability, and then you could do something like a live migration, take that VM, move it to a healthy server with no downtime. So that's how that all kind of ties together. Yeah, way in the back. So the question was, will it automatically detect my storage failure and do the failover for me? And the answer is no, but you could use something like System Center to do that. Not the base and box tools will do it. So what if we have a node failure? So what if I talked about how we would orchestrate metadata updates through one node in the cluster? What happens if that node fails? Excuse me. What we will do in our filter drivers is that if we notice a node goes down and becomes unresponsive, we will actually start queuing I/O in the for the virtual machines in our filter driver. We will then establish who will be in the new current cluster membership. We'll kick out all the members which have crashed and become partitioned. We will establish what becomes cluster membership. We will determine who will become a new leader who will now control all metadata updates. We will reestablish connections to that node, and then we will dump all the queued I/O to that node and catch up. So we can maintain availability and resiliency even through node crashes, and even node crashes of nodes which are acting as the coordinator. We can also handle network fault tolerance. So we have this network driver called NetFT. NetFT is this, if you ever do like an IP config/all in a cluster, we have this cluster virtual adapter. So it's a virtual adapter which we built these fault-tolerant TCP routes across all networks between the nodes in the cluster. Think of it as like our own little internal teaming driver. So we have our own teaming driver internally where we have fault-tolerant routes across all the interfaces. And in your clusters, you have multiple interfaces between the nodes, right? And then so if we lose an interface, we can route I/O over different networks. So we're completely resilient to storage failures, node failures, network failures. CSV can recover from all this. So I actually kind of somewhat answered this question already. This was how many VMs can I put? So there really is no maximum, and because we're doing I/O, we're doing metadata orchestration at the server side level instead of storage level, there's no limitation on the number of CSVs you can put on a VMs on a CSV volume. However, there is a consideration. And it really has to do with how many IOPS can your storage array handle. And this really goes back to talking to your storage vendor. I have no magical answer. So on a traditional, let me take a minor step back. Traditionally, on a normal server, a server has a hard time the server's the bottleneck. It's hard to get enough I/O off the box fast enough that you can saturate the storage array, unless you start doing crazy things like putting 4 or 8 HBAs in your servers. But I assume that a very small population of your servers are deployed like that. What's different with CSV is that now you not only have one server pounding a LUN, you have 16 servers which are all funneling I/O to a single LUN. So that has very different performance. Now you're getting I/O streaming off all these servers down to a single LUN, which can now hit the storage array. So now it goes back to talk to your storage vendor. Different storage vendors will tell you different things, and if they care or not. Some storage vendors, let me take a step back. The older storage arrays, you think about, I need this many spindles, and I need to carve them up to this sort of RAID set, and then I need to present, and I need to achieve this sort of IOPS. And that's kind of the old storage model. The new storage arrays, and they may have a lot of planning and how you need to think about your I/O. And the I/O depends on the workload as well, right? If you're running VDI across these clusters with just desktops, you're going to have a very different I/O patterns than if you're running SQL in these VMs. On the flip side, so where was I? So the new storage arrays. The storage industry is kind of evolving, right? Tiered storage, right? So storage arrays that can intelligently do data placement, where you don't have to think about carving up spindles in the RAID sets and calculating this all out, right? That they will do intelligent data placement on and they just have a pool of disks and they handle which ones they're going to set it on, and they're going to handle tiering of storage, and I have, SSDs on the front end with fiber drives and then low SATA drives on the end. So a new storage vendor may say, I don't care, right? Create one LUN, throw all your VMs on it. It doesn't really matter. The LUN is just this virtual abstraction, and in the storage array, I'm going to intelligently handle everything. So my answer is go talk to your storage array vendor, because the story is going to answer depending on your vendor. It's going to depend on the family of array you're using. All right. With all that said, I'm going to bring up top who's going to show you a little bit about CSV.
Thank you, Ellen. As you can see in this case, I have a quorum disk and a few available storage disks, and the cluster disk 2 is now shared with my file server. I have marked which disk I'm going to use for the CSV. It's currently exposed as a volume G to the OS, and enabling CSV is really simple. There is a nice little link. All you have to do is the prompt here only tells you that this is for Hyper-V VMs. And once you enable CSV, a cluster shared volumes menu shows up, and currently it has no volumes assigned, so it shows empty. But if you look at the Explorer, we have the cluster storage folder created, and there are no volumes in it. But as we add more storage to CSV, the volume mount points would show up here. So how to add a disk to a CSV? Just right-click, say add storage. We'll select the demo disk, and this would move the disk remove the disk from available storage and mark it as a cluster shared volume. If you expand this menu, it says it has the volume has created. If you look at Explorer, the volume is also now accessible, and you can applications can now start using this volume as part of CSV. Thank you.
So the key thing you saw there was that you can just take a normal NTFS volume. So let's say you have a standalone Hyper-V solution deployed today, and you want to move that LUN to being clustered. You can do that without requiring formatting or replacement of the data. And you can also take that volume and make it CSV enabled without having to reformat and refile system. So very, very dynamic and fluid, that you could take a snapshot of this volume, mount it off on some standalone host somewhere else for recovery or something, or backups or whatever you want to do. So very, very flexible. So network prioritization. So something new that we introduced so for the old people in the room who've been using clustering for a while, back in 2003, we used to have this concept of you could set priorities of your networks. And then in 2008, we rewrote the networking stack, and we said, you know what, people don't really need to worry about this anymore, so we took it away. And then in 2008, R2 came along, and we said, with CSV, and when I say we took it away in the sense of inter-node communication between the cluster, we're like, it's so lightweight, it's so small, people shouldn't have to worry about this. We shouldn't need KB articles and white papers all getting people jazzed up about this, because it really doesn't make that big of a difference. Now, With CSV, it actually does. So with CSV, I talked about that we're actually doing routing of metadata between nodes in the cluster, and we use one of the cluster networks. In failure conditions, we can actually end up routing a lot of data across those networks between the nodes in the cluster. So what we did is we needed to expose some way to be able to make it configurable, and so we exposed that via PowerShell that you can configure the priority. And remember with CSV, we also do have fault tolerance. So if one network becomes unavailable, we will dynamically switch over to another network. VM placement. So we introduced two things in trying to talk about the private cloud and what we're trying to deliver for virtualization. So one thing we did is we introduced this thing called no auto start. Anybody who uses VMware, you can think of this as disabled. VMware has the priorities, high, medium, and low. And so we basically have high and we have low. So that's the way to think about this. And we just call it no auto start. I personally kind of hate the name, and I'm on a little jihad that we're going to change that at some point in the future. It's just very confusing. I don't know. We didn't come up with anything better at the time. Persistent mode. So what persistent mode is that let's say you go and shut down your cluster, and you've got 1,000 VMs running on this cluster. The traditional behavior with a cluster is that when you start it up, as those nodes that are first coming up into the cluster start, they're going to start starting all the resources. And if you've got a 16-node cluster with 1,000 VMs, you don't want all those 1,000 VMs to try to fire up on those first couple nodes that come up into the cluster. So what persistent mode is, it says, wait a little while. And we have a little timer to try to give all the nodes time to come up into the cluster. And then we try to go place them back in where they originally were. So if VM 20 was running on node 2, we try to put it back on node 2. If VM 40 was running on node 4, we try to put it back on node 4. So we remember when you shut down the cluster and then try to place VMs back where they were. Another new feature which we added in 2008 R2 is we added PowerShell support. So historically, our command line interface has been cluster.exe. Cluster.exe is almost kind of like a direct mapping of our API, of our cluster API. So it's not very friendly. In 2008, we really changed the whole paradigm for clustering to try to make everything easy to use. We wanted to bring that ease of use functionality from just being in the wizards down to the command line. So if you think about like a script to create a highly available file server, or creating a highly available file server, in the GUI, in the snap-in, we have this nice little wizard. Prompts you for like 3 things, boom, and you're done. But doing it through the command line, through cluster.exe, would be a big, long script. So we wanted to bring a single wizard experience to the command line that just prompt you for those 3 sorts of variables which you would get prompted from the snap-in, and bring that ease of use. So that was kind of our big vision with PowerShell, was not just to adopt PowerShell, but also to bring the ease of use of the GUI to a command line interface. And here's just some of the commandlets. We also added a lot of, I talked about our VM integration, that Hyper-V is really important in enabling the private cloud. So we enable things that you can do quick migrations, live migrations, all through VM configuration updates. You can do that all through our PowerShell command list as well. So we have this really tight integrated story. Reduce cluster access. So one of the requests which I'd hear from now and then is people would say, you know what, I want my help desk to be able to see the status of what's going on in the cluster. When I get some mom alert, or some ops manager alert, excuse me, which says, resource failure, before my help desk, tier 1 help desk, calls me at 3 o'clock in the morning, I want them to actually figure out, did the cluster restart that resource and I don't need to get out of bed and go log in and figure out what's going on and everything's actually up and running, or are things in a bad down state and I need to take action. So what we added was read-only access. It's exposed either through the API or it's also exposed via PowerShell, that a tier 1 low-level access where they only have read-only access, so they could go look at the status of the resources. Are they online? Are they offline? Are they failed? And then before they call you and say, oh, look, horrible things, you need to get out of bed. So that's part of the goal with this. We also added performance counters. So that you can measure, like you want to measure CSV traffic. What are we sending across this network? What are we sending down? And how much are we sending? So you can actually go and look at things like that. This is probably more interesting to like our devs, probably more than anyone, but you can, or people who are ISVs, you can actually go and look at cluster API calls and updates to the database and all kinds of really hardcore things. Yeah. For what? So our PowerShell is either available, yes, if you install RSAT. So the question was, how can my tier 1 guys get access to this? If you install the RSAT tools, our PowerShell commands will be installed with the RSAT tools, and then you can do read-only access. So you can install that on your Windows 7 desktop. We also added more logging in R2. So the internal philosophy was print screen should never be a troubleshooting tool. So a lot of times, you know how you get these little pop-ups, and then somebody clicks OK, and then they call you up and go, yeah, I got this pop-up. And you go, well, what did it say? And they go, I don't know, something like there was something broken and something like that. And you're like, well, what am I supposed to do now, right? So any event which we throw up into the GUI, we throw it into an event log channel so that when somebody calls you up later and you got this pop-up in the GUI and you're trying to troubleshoot things like this, we capture all the stuff now. So we just added a bunch, and we added some more debug logs so you could go turn them on, like have WMI tracing now. You can go turn that on if you're trying to debug a script or you're an ISV. We also we have this global view of collecting events across the cluster. So we have this event queries where we can query all the nodes. You can bring in custom channels, and we can also save those off. So if you go do this custom query, you query cluster events and SQL events, you pull them all into this nice aggregated view, and you want to send them off to someone to look at, you can do that. So we have a save as functionality as well. And with that, I'm going to bring up Amitabh to show you a little bit about the venting.
Thanks, Aldo. So it's very easy to see what events are there in your cluster. If you click the top link for your cluster, there is a recent cluster event which lists all the various events. In the last 24 hours, there is none, so you can't really see anything. But if there were any resource failures or a group being moved to a different nodes, you would see some events here. You could also, so now we are looking at the file server group. So you can view this specific group's events by just clicking on just show critical events for this group. And it says that, okay, there was some resource failure on 5/13. And you could also see it just by clicking on the resource level information and this show critical events. And so you could get the same information at a cluster level, at a group level, at a resource level. And we provide you this nice query interface where you can actually write queries specifying what date and time you want. So you specify the nodes that you want to get the events from, and these are various channels that you can select from. By default, it's the failover cluster and system channels, which it's selected. The level is critical error warning, but you can certainly have informational events also queried as part of it. And you can specify the start and end date for it. In this case, I'm just going to select, I'll go a few days back and just run the query, and it shows me, okay, there is a lot of errors and warnings and critical events that happened in past week. But by default, it shows only the last 24 hours, which had none. And if you select a particular event, it gives you a little bit more in-depth information about it. You could also save this query, and a saved query would basically look like just an XML file, and you can run it again and view it in the event viewer. Thanks.
All right, so some other things that we added in R2, we added support for DFSR. So DFSR can now, so let's say you have your corporate office, and you want to be able to, which is a cluster, and then you want to be able to do replication of file services off to your remote branch offices. You can make DFSR be part of a replicated set with DFSR now. Remote desktop connection. So we also added support for making your remote desktop connection broker highly available on a cluster. And we actually have a wizard that will walk you through how to set that up and get it configured in a highly available fashion. So this is just another one of the new roles which is new on R2 clusters. Print server. So if anybody has a print server, I highly recommend you get to R2. And one of the big availability wins actually has nothing to do with clustering per se, but they have this new sandboxing of spooler processes in 2008 R2. So I can tell you, just in historically working, that it's, you have this highly available file server, and then you always have some admin who has some label printer or something, and they want you to put some junky print driver from some no-name vendor and put it on your highly available production system. Well, then the problem is that this junky print driver made by some college intern, if it has problems, it can bring down the whole spooler process in all the print servers, right? So you have this highly available print server with hosting thousands of print servers for everything, and this one junky driver can bring down the whole print spooler process. So in 2008 R2, there is this new isolation which will help isolate drivers, and they can help reduce the impact of that. And then they also will periodically, to help address memory leaks, they'll do recycling of different sandboxes. So this will help increase the overall availability. So I just kind of recommend this in general, clustered or not, get your print servers to 2008 R2. Data center management. So you can also manage your clusters through SCVMM, and there's a lot of tight integration that you see with VMM, and I'm going to talk about some of the new cool things coming in 2012 in a minute. We also have management packs for clustering, which plug into Ops Manager, which you can use to monitor your clusters. So we have tight integration with not only VMM, but also Ops Manager to enable management from a virtualization layer and also from a monitoring of your status of your cluster. So let's talk a little bit about VMM 2012. There's a couple new cool things in 2012. So I'm not talking about all the things, but I'm just going to talk about the things which are relative to clustering. Since I'm the cluster guy, these are the things I care about. So one of the things is that you can configure SCVMM to be highly available now on a cluster. So people would say, SCVMM is very important to me. I want to make sure that if the server which is running SCVMM becomes unavailable, then I can configure it in a highly available fashion. So now you can do that with 2012. You can configure VMM to be a highly available application, just from the low-level infrastructure perspective. Now when it comes to managing clusters, one of the new cool things is that I hear people tell me that setting up clusters can be painful, right? That you have these 16 servers which to be nodes in a cluster, and I have to log into this one, and I do the networking configuration, then I got to do the stores, and I got to do this, and then I got to go rinse and repeat 16 times through all these servers. How can I simplify deploying my clusters for my private cloud? And VMM 2012 really allows you to do that it will allow setting up a cluster from bare metal to putting the base OS on it for the host partition, to configuring the cluster, to joining it to the cluster, to putting virtual machines on top of it, and top to bottom, soup to nuts, and the whole scenario, VMM 2012 can handle that. So that's a really nice advantage of deploying and managing clusters. If you think it's painful, this can help alleviate some of that. There's also a new patch maintenance orchestrator built into VMM 2012, which will actually manage working with a WSUS server. It will go actually query the nodes in your cluster for the host partition, look at all your nodes, figure out what patches they're missing, go out to a WSUS server, pull down the patches, apply them to nodes, and it will actually use node maintenance mode to actually drain a node, move all the VMs off of it, pause the node, apply the patch, reboot it, and then work its way through all the nodes in the cluster. It'll go through each one saying, okay, now let's go to the next one, let's pause it, let's drain it, let's patch it, let's make sure the patch is successful, and move through each one. So this can make Patch Tuesday much, much less painful in managing your clusters now with VMM 2012. They also have dynamic optimization. So this is load balancing of virtual machines. So what VMM 2012 can do is it can actually look at your cluster. And remember, you can live migrate VMs around on your cluster now, right, with no downtime. Well, what it can do is it can go look at performance characteristics of your different nodes and go, well, maybe we should move this VM from node 1 to node 3 because node 1 is sitting at a high CPU utilization. Yeah.
And it does that about SCOM now?
Yes. So the magical question is, well, I could do that before. Couldn't I do that before with SCUM and VMM and a combination using pro tips? And the answer is you could. Now we have a holistic solution all built into VMM. So a nice shrink-wrapped complete solution. You could kind of do it before, but it was a little more duct tape and super glue than it should have been. Power optimization. So this is kind of cool. I kind of call this a green cluster. So imagine that you have your cluster with a whole bunch of VMs, and when you're running a 9 to 5 shop, when everybody goes home on the weekend, these clusters, you got a 16-node cluster just sitting there just chewing power, right? Well, how about when everybody goes home on the weekend that we take all those VMs and we squish them down from running across 16 nodes to maybe down to like 10 nodes, and let's go power off some of those nodes in the cluster. And so it will do this for you, so that you could set it up to either do it on a time-based interval, like most people go home at 6. At 7 o'clock, let's start pushing all the VMs off these nodes and start powering them down. And then at 6 a.m., before everybody starts showing up at work, let's start firing up the nodes back up again and start live migrating them back to the other nodes. So this is all zero downtime. You could also do it based off of performance characteristics. So you could say that if nodes in my cluster start reaching CPU thresholds, meaning I need more resources, start powering up more nodes, and then dynamic optimization will kick in to redistribute the VMs across those nodes. So this is pretty cool. So let me talk a little bit about what is happening, or just happened actually, with 2008 R2 Service Pack 1, and one of the changes or fixes that kind of went into there. I'll just talk about it briefly. So there were 24 cluster fixes that went in. We had one design change that went in, which was really around asymmetric storage. I'll talk about in a second around making clusters more configurable. What's most important in my mind about are there any real critical fixes for clustering in SP1 that I'm saying, go now, go now? And the answer is no, not really. But there are a bunch of networking fixes. So if you have been, every once in a while I stumble across somebody who's been plagued by some challenges. So one of the things about clustering is that we're actually monitoring the network health between the nodes in the cluster. So sometimes I run into people who say, you know what, I have all these networking problems on my clusters, but I don't have them when they're not in my clusters. So my standalone systems are fine, but my clusters are having these networking problems. And my analogy there when I think about that is that there's nothing special about your clusters. It's kind of like you have cancer and you have a tumor, but you never go to the doctor, and you say you feel great, right? We're just a health monitoring, right? We're just detecting that you're having networking problems, and the problem is you probably didn't know about it until clustering came along, and we're monitoring that you have problems. So there are some networking fixes in SP1, so I recommend if you're having some networking problems or if you've had some challenges there, get to SP1. Now, my one big disclaimer is that this is my moment of shame. I'll take my moment of shame. All right, so we did have a bug that we introduced in SP1. So I do want to say that if you guys do deploy SP1, make sure you do get this hotfix at the bottom, this 253.1907. It's really specific if you have more than 2 nodes in your cluster. So I just want to say, if you get anything out of this presentation and you go home and a month from now you're deploying SP1, I just want you to have this like spidey sense in the back of your brain going, wait, wasn't there some hotfix I needed? So if you get anything out of this presentation, if you walk out of here with that, I'll feel good. SP1 also includes, we have a KB article which lists recommended hotfixes for clustering. It includes all those. There's also kind of a critical hotfix for print servers. So if you have deployed an R2 print cluster, there is kind of a roll-up print package which is critical. That's also included in SP1. I'm just saying it's there. I included a master list if you guys want to have a reference after the show, and you'll get all these PowerPoints obviously on your DVDs after the show, post-show. So I just gave you a list of all the hotfixes here just as a high geek factor. So let me talk about a little bit about the design changes that went into SP1. So one was an optimization we did around asymmetric storage. So clustering in the past assumed that all nodes saw all pieces of storage, right? And in order for the assumption a lot of our wizards and validates and our tools made was that a LUN must be seen by all nodes to be valid. So if you're going to add a node to a cluster, it must be seen by all nodes. We basically changed that algorithm from saying LUN must be visible by all nodes to a LUN must be visible by 2 or more nodes. So we changed that. So if you look at this configuration, here I've basically got a LUN which is on, this might be like a geographically dispersed cluster. I've got a LUN on site A, which is a LUN or a SAN, which is visible to nodes 1 and 2, and I have a totally different sand on the other side, which is visible to nodes 3 and 4. So this is just a lot of optimizations we did around trying to make the user experience better. So if you deployed in this model before, you could get around a lot of our wizards and pain, but you'd have to go to the command line, you'd have to go to cluster.exe, and kind of backdoor around all of the checks we did. So I'm just saying now we give you a better experience. The other change we made, this is actually in a QFE, which is a post-SP1 QFE, which came available like a week ago, which I just thought I'd make you guys aware of, which is another DCR we recently did, new feature. And so what it introduces is the ability to configure node weight. So cluster quorum, let me take a step back. So a quorum in a cluster is a majority of votes. And different things can have votes. Nodes can have votes, and you can also have a vote assigned to a witness. And the witness could be either a file share or it could be a disk. So you need a majority for the cluster to stay up. So let's say you have a 5-node cluster with no witness of any kind. You just have a 5-node cluster. Traditionally, you have 1 vote assigned to each one, so it's 5 total votes. So you need 3 out of 5 for the cluster to stay up and functional. And we really gave you no flexibility to select which nodes could have a vote and which nodes could not have a vote. So we kind of put this burden from a deployment perspective that when you were deploying your cluster, you had to sit there and think about it ahead of time. You had to go, well, let's see, I want to have an odd number of votes, so I need 5 nodes, right? And then it became a pre-deployment decision. And so we really want to simplify that. So now we have the flexibility that you can decide which nodes have a vote in cluster membership in determining quorum. So you're now empowered to say either you have a vote or you don't have a vote. This might be most commonly used, I think, in disaster recovery in multi-site clusters, where you say, I never want to fail over to this site automatically, that you might just go drop all the votes on the nodes on the other side. So you go, no, you guys have no votes. The primary site will always win. I will only ever come up over here unless I manually go force this thing to come online. And there's actually a KB article. So if you go search this KB article, I got a lot of information about how this new functionality works. And we entered a new switch for the cluster service as well when you start it. So it's called Prevent Quorum. It's in there as well. So dynamic memory. So one of the other big features, this really kind of has nothing to do with clustering, but I thought I would mention it anyway. One of the big features in Service Pack 1 is dynamic memory. So this allows, traditionally, memory is one of the resource bottlenecks associated with a virtual machine. And so this allows the memory of a virtual machine dynamically to grow and shrink based off of demand and availability. So this is one of the big features I just want to mention that is in SP1, which is something people have been looking for a long time around enabling their private cloud. All right, so just as a quick recap, I just want to say that Failover clustering, we are the foundation that enables the private cloud. There is a lot of value in going to 2000 R2. A lot of people go, there's just this little R2 slapped on the end, right? How big of a deal can it be? There must just be a couple of fixes. I don't really care. Answer is, from my perspective, it's like an entirely new release, right? This is the Windows 2000 R2 is the server name slapped on top of Windows 7. We added a lot of new roles. We added a lot of new big features like CSV, live migration, big, important features, even though this is just supposed to be a little R2 release. So there is substantial value. And no additional requirements as well. All right, and my last kind of closing thing is I just want to say thank you very much. And I also want to say, make sure you fill out your evals. My livelihood as a tech ed speaker is dependent on your evals. They actually take them very, very seriously. So if you loved it and you want to see me back doing more, tell me you love it. If you hated it, you don't ever want to see me again, you're empowered to do that too. So thank you very much. Any questions? I saw a hand. Yes. So I missed the very last little question. Live migration other than? So the question is, being able to, I'll reinterpret this. So the ability to remove virtual machines for planned downtime with zero downtime is beautiful. I'd love it if you guys did this with other things. Like, why can't I move my SQL server from one node to another one with zero downtime? Is that kind of what you're saying? Yes, we're definitely working on, we realize downtime is bad, and how can we make things better? So we're definitely working on other workloads to try to make availability more available. Yeah.
My question is about live migration. How many simultaneous live migrations can you do, like in a planned maintenance scenario where you're trying to evacuate maybe one host to do patch management? How many simultaneous live migrations could you do across the cluster? Is there a limitation between individual nodes, or would it just space them out between nodes and you'd be able to do more live migrations?
So the answer is that we can support, so it's kind of a loaded question, but I'll give you my loaded answer, or my skewed answer. So the answer is that we can support one live migration for any given, for a source or a destination. So you can either have one live migration going out, and from any given receiver you can have one coming in. But that means on a 16-node cluster I could potentially be doing up to 8 live migrations at a time, like 1 to 2, 3 to 4, 5 to 6. It's somewhat of a loaded question, I say, because VMware can do this. And some people go, this is really cool, I can do this faster. So I'm going to give you my slightly skewed Microsoft perspective on this. The pipe, it's a funnel, right? And the pipe off the server is only so big. And if you think about doing a file copy, if you're going to copy 3 2-gig files, does it really matter if you copy them 3 2-gig files at the same time, or if you copy them one after the other, and you do them serialized versus parallelized. And the pipe's only so big, right? You got a 1 gig interface, there's only so much data you can push through it at a time. So whether you do it parallelized or serialized, my perspective is it's about the same. Another thing to think about with virtualization is that you could argue if you parallelized everything, it's going to take longer. If you're doing 3 2-gig copies at the same time, each one is going to take incrementally longer, right? And you got to remember that we're doing multiple passes, and it's dependent on and the data is changing, and we're tracking that in a bitmap. So then that gets longer and more. And then, does that make sense? And then the third thing, which is actually, I've seen people go hold up stuff and say that VMware actually goes faster when doing parallel live migrations. And actually I would totally agree with that, because they were incredibly inefficient about it, and they actually addressed all those issues in ESX 4.1.
So the follow-up question to that would be, you guys are not going to move in a direction to do multiple live migrations, or you want to do it better than they're doing and you do want to go in that direction?
I'm saying I hear your feedback, and it's something we're very seriously thinking about, and I can't talk about vNext yet, but we're working on those sorts of things. Although I don't think partially what I'm saying is I don't know that it's really that important. And you could throw me a bone as a jaded Microsoft guy too. The what? The slides what? Oh, can you get the slides? Sure. If you want to come up to me afterwards, I can give you my email. I give you my business card, and you can send me email. I'll send them to you. They're also going to be on the post-show DVD that you will get them. More questions? Yeah. I'm sorry, I'm having trouble hearing you. Oh, sure. You want me to go back to fix the slide? You want this one or the previous with the critical fix? You want this one? This one? Okay. Yeah. So the question was, do 2008 clusters still need a heartbeat? So let me address that in a couple different ways. So the short answer is we actually do heartbeats across all interfaces. So if you have a private network and a public network, there's really no heartbeat network per se, because we're heartbeating across all networks. There's two things we do want to have. One is resiliency. So that's why we say we like to have at least 2 network paths between the nodes in the cluster, is we want to have resiliency, that if I can't talk over one interface, I can talk over in another one. Another thing we want to have is quality of service. So cluster heartbeats are very small, they're very lightweight, but we're sensitive to latency. So if for any reason that let's say you didn't have an internal isolated cluster network, you're just sending everything over the public. It would work, but if for any reason that network started to become saturated by internal clients, that could get in the way of our heartbeats being able to get through, and then we may falsely detect nodes as being down, where a network could get totally saturated, our heartbeats can't get through, and then we go, oh, node's not responding, something must be wrong, we'll shoot it, kick it out of membership, and so we could have false failovers. So that's why we still say, but there's many ways to architect your network to achieve that. We just need resiliency, and we just need quality of service. So you can do VLANs, and you can do all kinds of, NIC teaming, and I'm fine with all that. So the question was, do all nodes have to be in the same VLAN? And the answer is no. With 2008, we actually added multi-subnet support, so you can have nodes which reside in different subnets. The one caveat of this is that SQL does not support this today. All workloads do except for SQL, and SQL is actually adding support in the Denali release, which is the next coming release, so it'll be out shortly. They will have support soon. Yeah? Sure, so the question is, can I run multiple workloads on the same cluster? The answer is yes, you can, with a little caveat. Most people don't, so I'll just say that. Most people don't. Most people tend to say, here's a file cluster, here's a SQL cluster, here's my print cluster. And they tend to keep them segmented. You can mix them together. File and print's the common one. The only real caveat to this, I'll say, is Hyper-V. Hyper-V likes to say, don't put anything else in the parent partition. If you want to make the file server be highly available, stick the file server inside of a VM on top of Hyper-V, but don't put it in the parent partition. Leave the parent partition just for Hyper-V. Lots of good questions. Any more? Yeah. So the question was around the patch orchestration within VMM 2012, and does it move the resources back? The answer is yes, yes and no. So in the sense of what will happen is it serially walks through the cluster. So it goes through node 1, moves everything off, patch it, reboot it, goes to node 2, move everything off. Now when it goes to node 2 and moves everything off, it's going to try to do intelligent placement to try to look at the nodes. Now, obviously, the node it just patched is going to have nothing on it, so it's going to want to move everything to it as a preferred. And then it's going to kind of work its way to the next cluster, to the next node, and it will probably move back to where it just was. And so things will kind of follow behind it. And then what will happen is ultimately when it's done patching completely, then the placement optimization will kick in, and it kicks in and goes and looks at all the different nodes in the cluster, and then rebalances things based off CPU and I/O perf characteristics. So the answer is, if you gave it an hour, yes, you would end up there. Does that make sense? Yeah. So the question was around how do we keep, how can we be intelligent to try to keep movements to a minimum and not just keep live migrating the same VMs all around with VMM 2012? Actually, I don't have a good answer to that because I'm not from the VMM 2012, but there are people down in the booths, Carmen is down there in the 2012, and she's the PM who drove this feature, so you hunt her down, you say, Eldon sent you. Are there any questions? All right, thank you guys very much. I hope you enjoyed the session.